Alright, so sorry about the time lapse. It kind of just stopped 2 minutes in, which was really unfortunate because it was actually looking kind of cool just getting everything set up, but ta-da, it's done. So we got the charge tank, we got the pressure tank, we got our new vacuum pump, which I'm stoked about, and it was a really good deal on Amazon, so I'm really glad I invested my money in a better pump. Otherwise would have been a little less efficient in the final product. But later today, in about an hour or two, one of the guys is coming over, one of the other guys on the team, and we're gonna test. We're gonna finally get this up and running. We're gonna actually test it and record some data, punch some numbers, see how much thrust we're getting out of it. I calculated the theoretical exhaust velocity today and what flow rate we would get based on what pressure we put it at. So I'm excited. Just a little bit of an explanation. I know in the last video I posted a little kind of clip of it was the clip of the nozzle turning on, but it wasn't turning on, it was kind of sputtering, and I heard from some people who said they thought it was a pulse jet engine. They didn't know we were doing a pulse jet engine. Well, we're not doing a pulse jet engine. The reason it was doing that is because we didn't have enough pressure, and so this check valve kept turning off and on really fast, kind of like a pulse jet engine's check valve would. We don't want it to be a pulse jet. It's not as efficient as an actual rocket engine, and this will be an actual rocket engine, so we don't want that sputtering. We want it to turn on and just be a solid flame out. You think I'm good? Okay.
Yeah, Joe, you're safe. You'll live.
It's still burning.
Oh, cool.
Oh, that was nice.
Wait, bring it over here.
Sure it's burning still.
Oh, it's still going.
Oh, it's on fire.
Oh,
It's on fire. No.
we just ran the nozzle. It actually turned on, which was good. It didn't backfire, but
Didn't go back.
the tubing got too hot.
Yes,
so
and it caught fire.
well, you can see here, it caught on fire, and we're gonna go get some copper tubing and be right back.
Joe is very excited.
Well, now I know it's not gonna explode.
Now you know it's not gonna explode.
So I won't be as.
You might catch
I
fire,
won't-
but it's okay. No, we have another person replace him after this.
You do?
Yes.
Uh oh. 4. You ready?
Mm-hmm.
All right. 3, 2, 1. Oh, well. Did you
That
see
was
what
slow.
happened? All right, so that last test was very successful, except the nozzle kind of. Yeah, take a look at that. Burnt a hole straight through the side.
That's awesome.
And this is why you don't make nozzles out of plastic, huh?
Yeah.
So
Next time, aluminum.
yeah, I'm gonna mill one out of aluminum this weekend, I think. Just another one of these. It might have a little bit of a bigger area ratio.
Yeah.
But you weren't recording the exhaust, so I can't tell if it's
Yeah,
under or
because I was on the other
overexpanded.
side.
So
It's all my fault because Joe says so. It's all my fault.
no, but look at that. It's all burnt up in there.
It's crusty.
But hey,
it works.
we're getting places. It's
Yeah.
working. So we're gonna trade it out for this 4 point. What is it? Hold on.
What is the exact ratio?
163. 163. 4.163 area ratio nozzle. It's been used before. You can kind of tell it's a little.
Isn't it the
burnt up,
second
but
edition or first?
This is the first revision.
First revision.
There is a second revision, but actually no, this is the second revision.
Oh, okay.
The first
Because
revision
the first
I
one
didn't
was
print.
the okay.
And
thought
then
the first
no,
one was
well, this isn't the first revision. This is the 33. Well, actually, it's 333 to 1 now because I put a micro nozzle in there.
I saw.
But yeah, this is the second revision of the 416. We didn't print the first version.
Why not? Was that bad? Just kidding.
I messed up.
Okay.
All right, so we tried, but it's proving rather difficult to get the copper tubing inside of this. It's a little bit of a different connection than the other one, so I think we're just gonna wait.
And we also have to sand it down more.
Yeah. So I think we're just gonna wait to to mill out the aluminum one.
Yeah.
So. Because it won't melt.
We're defeated.
Yeah. No, we're not defeated.
We're defeated.
We just can't
That's
finish.
it.
We just can't finish it tonight. I was hoping we were gonna get all the tests done for that nozzle, but it melted way too quickly.
Yeah.
I mean, I could 3D print it with solid infill.
Can you?
I can, but it probably just melted at the same rate because this gas, the oxy-hydrogen, burns at a little over 3,070 Kelvin, I do believe.
What's Kelvin to Fahrenheit?
Kelvin to Fahrenheit? I have no
that.
idea. Kelvin
Okay.
to Celsius is like plus 273 or something like that.
I remember doing that in physics.
Yeah.
That was bad.
Physics buddies!
Yeah. I
Yeah!
don't like physics.
So, after several weeks, we were finally able, or I was finally able, to machine the nozzle. This is just a aluminum reference part. The nozzle's already mounted outside. So we're going to be testing it today. You probably can't tell, but we made the second drill that drills out the ignition chamber, like just the middle of it, and then we go in with a boring bar. But we made that first initial drill go a little too deep. I don't know if you can see, but it messed up the radius inside. And that geometry is one of the most critical tolerances of the nozzle. But luckily we fixed that for the stainless, 304 stainless nozzle. 3, 2, 1. Alright, so we were able to hear it turn on, but there was no flame out. I'm gonna try it again, with a little more pressure. In 3, 2, 1. So we got one of the guys here from the Project Guardian team, Jair. He was in the very first video, one of the first founding members of the project.
Yes. Founding father.
Anyway, that's not important. What's important is I'm kidding. So we're testing this nozzle. We haven't filmed much of the nozzle tests because they've been largely unsuccessful. Mainly due to
Pressure.
yeah, we need more pressure.
In conclusion, mosquitoes.
Yes,
Cut the day
the
short.
mosquitoes are terrible out here. So we're gonna test it one more time and we're gonna film it. And I think that's gonna have to be the end of this video, and we're gonna have to make it a 3-part video. Originally I was planning on making it a 2-part video, but we're just it's gonna take a little bit longer to get it running than we were thinking. So sorry. We're gonna mix some electrolyte. So now that we have this baking soda measured out, there's 180 so grams. The ratio is 1 liter of water to 57 grams of baking soda. And we're gonna do 2 liters, so we have a little bit more baking soda, but that'll be all right. Lovely assistant, please take the scale. And we're gonna fill it up with 2 liters of water, and there's a little mark in the bucket to do that.
Where am I supposed to put it? There's a freaking car in the way.
Ready?
So what are we gonna do?
I'll try simultaneous and see what happens.
Simultaneous? Well, you first, and then I'll go.
I'm gonna go 3, 2, 1.
3, 2, 1. Off.
Out of fuel.
Yep.
Goodbye, loyal acolytes. Goodbye.
Thank you guys so much for watching. We'll see you in the next video. If you like what you see, give the video a like, subscribe, comment in the section below if you have any comments, feedback, questions, concerns. Anyway,
This is legal, right? No, I'm just kidding.
we'll see you guys in the next video. Thanks for watching.